All right, so in this example, we are trying to figure out what this distance is, and we've got two coordinate points. I'm trying to figure out how far apart these are. But hey, look, even in this diagram, that's a 90-degree angle. Now we actually do know where this point is. It's 1, -4, and this point up here is 5, 6. But if we wanted to figure out how far apart this is, that's from 1 to 5, you know that. It should be 4. All you have to do is do 5 minus 1. Or, more technically, what you're doing is you're doing the x value of the second point minus the x value of the first point, x2 minus x1. If we wanted to figure out how long this piece was, it goes from -4 to 6. We know that those are 10 apart, but we can do the same idea of trying to get that value. We could do subtraction again. 6 minus -4, that will also get us 10. So what we did is we did the y from the second point minus the y from our first point. We could put those two numbers, 10 and 4, into the Pythagorean theorem and then square root, and we'd find our distance because it's a right triangle. That's all the distance formula is. It's going to look scary. I'm about to show it to you. There it is. The distance formula is just an application of the Pythagorean theorem. This is one of the legs of our right triangle. You could think it's this bottom piece right here. And then this is another leg of our right triangle. So this red piece right here. And then the distance is just the hypotenuse. But we don't want the distance squared. We just want a distance. So we square root. That's where this all comes from. So if I wanted to find the distance between these 2 points, I don't need to make that whole big graph. I can just put them into the distance formula. What I like to do, especially when I'm practicing, is I want to make sure that I'm labeling this. This is the x value of my first point, and then the y value of my first point. This is the y value of the second point, and then this is our x value of the second point. So when I'm trying to find my distance, I just kind of copy the information that always stays the same. So I'm going to subtract a couple things and I'll square them and we'll add them. And then we'll subtract a couple other things and square them. So my x values are 2 and -3. So I want the x value from my second point, which is 2. So I need a 2 right here. And then I need the x value from my first point. The x value from my first point is -3. So I'll put that in. Then I need the y value from my second point. That's 3. So I'm going to put a 3 right here. And then I need a y value from my first point, which is 1. So I put a 1 right there. Now it's all plugged in. I just got to simplify it down. 2 plus -3, that's 5 squared. And then 3 minus 1, that's 2 squared. Still all being square rooted. I haven't done any square roots yet. So 5 squared, that's 25, plus 4 equals the square root of 29. Now I need to try to simplify that. So back to the calculator. We should be pros at this by now. 25. No. 29 divided by 4 squared, 16. No. 29 divided by 3 squared, 9. Nope. 29 divided by 4 squared. No. Oh no. The only one that worked is 1. Oh, but that means we don't have to do anything. Sweet. All right. Okay. One more example and we're done for today. So same deal as before. I've got the x value of my first point and then the x value of my second point. This is the y value of my first point and then the y value of my second point. I copy the information. That's not going to change. And then I need to plug in my information from up here. So the x value of my first point, I can't quite show it. So the x value of my second point goes right here. And then the x value from my first point goes right here. The y value from my second point goes right here. And then the y value from my first point goes right here. Now I just need to simplify. 2 minus -2, that is 2 plus 2, that's 4, plus 5 minus 1, that's also 4 squared. So I get the square root of 16 plus 16, which is the square root of 32. Okay. I might actually know that one. I think it's 16. So 32 divided by 16. Now, a way you can check to see if you've definitely found the best one is you take a look at this number right here. That number right there is prime. You know you found the best one. If it's not prime, you can hunt for perfect square factors in that one. You find some, then you haven't found the best perfect square. So go back to the drawing board. But I got a prime number out of taking out this perfect square, so I know I've found the best. So I got square root of 16 and square root of 2. The square root of 16 is 4, and the square root of 2 is nothing good, so I'm just going to keep that. And notice that I didn't do any plus or minuses on this one because distances are always considered positive. You can't have a negative distance. And that's it. So keep in mind with your Pythagorean theorem that it is always the two legs getting squared, and then the hypotenuse is always by itself. The hypotenuse, there's two ways to identify it. It is the longest side, and it is opposite of the 90 degree. That's all for today. Thanks for watching.